Hey kids, welcome to Objective 6. We are going to be continuing to talk about rational and irrational numbers. The objective is discussing these numbers in decimal form, but as an added bonus for you, we will actually be talking about rational and irrational numbers as they relate to fractions as well. Actually, we're going to be using that as our leading up point and then get to decimals at the end. Here's a funny comic for you that you can come back to after our lesson. Right now, it may not be very meaningful, might not be very funny, but in about 15 minutes, that might be pretty funny. Give you a little chuckle. Okay, so a rational number, we see ratio in here, makes us think of, proportions, fractions, right? A rational number can be written as a fraction. Okay. And then we have irrational. Ir is the opposite of rational. Well, a number that is not rational cannot be written as a fraction. And the next part of our conversation all hinges on this point. It's not our main point, but man, it's an important one to remember as we go. So we're going to actually bop all the way down to the bottom of this worksheet. We're just going to go back and forth all over the place here. And let's first talk about these numbers as they relate to fractions. Now you know that 6 can be a fraction. It would be 6 over 1, or 6 divided by 1 is 6. So because 6 can be written as a fraction, it is an example of a rational number. This is read 7/10. It means literally 7/10. And because that number was just written as a fraction, that means that we can justify that the number 0.7 or the decimal 0.7 is a rational number. Now here, this is a new number that we've just been studying, a new type of number, a repeating decimal, which we learned if one digit repeats, it goes over a singular 9. The thing that's repeating is the numerator, and so we get 4/9, which is a fraction. So that means a repeating decimal is a rational number. This is a square root. We haven't been working with those much. What those are means what number times itself gives you this number here. It's called a radicand. So the number 5 times itself will give us 25. And of course, 5 can be written as a fraction, 5 over 1. So it seems that some of our square roots can be rational numbers. If you are stuck, not really sure what a square root is, if you look at your calculators, that square root symbol is above the number 7 on the little keypad there. All right, 97%. Well, the phrase percent means of 100. So 97 of 100. So a percent, it seems, is able to be written as a fraction, so therefore is a rational number. Okay, what about the number 0? Now the first question is, why would you ever write 0 as a fraction even if you could? I can't think of it of a reason why you would do that, but if you wanted to, could you? Well, yeah, you could divide 0 up into equal pieces and have nothing left over, and it would still, be legitimate. It'd be okay. So 0 can be divided into any number of parts, but I'm going to write 0 over 1 to keep it consistent with this rule where a whole number can be written as a fraction over 1. So 0 is also an example of a rational number because it can be written as a fraction. All right. Well, shoot, it appears that all of these are going to be rational numbers. Let's see here if we can find an irrational one. This one's negative, whole number 7 and 3/10. Well, there's another fraction there, so there is another number that can be written as a Fraction. I'm running out of room. I'm going to write mine up here. All right. Let's see if maybe we can find some irrational numbers. So here I have a number a decimal that has the ellipse after it, the dot, dot, dot. And remember the rule is if you're going to write a repeating decimal without using bar notation, with using that ellipse there, that you need to repeat the digits 3 times before you put that series of 3 periods. So if this were repeating, I would need to write 0.425425425 dot dot dot. But because it's only singular, we can assume that this number doesn't have repetition. So it's just a bunch of numbers that we don't really know right now, we don't honestly care, that go on and on and on with no sense of repetition. Now, if this were just 0.425, we would say that it would be 425 over 1,000. But that number goes on. So if after this 5 there's, say, a 3, I just made that up, then I need to extend my denominator, because this would be 4,253 10,000ths. Let's say there's another number, and if there is, then there needs to be another 0. And this numerator continues to grow, and as the numerator continues to grow, then so must the denominator to match it. And if the numerator never ends, as shown by that little dot, dot, dot there, then neither does the denominator. So that means that while we can write an increasingly specific or correct fraction, it's never going to be perfect. So that said, that this number can't be written as a fraction, so therefore it is an irrational number. Okay. All right, similarly, if you look for the square root of 5 using your calculator, again, using the square root button above the number 7 on the keypad, you will get 2.236, and it goes on and on with no sign of repetition. And of course, those digits end at the end of your calculator, but we know that that number doesn't actually end. It just ends physically because that's where the calculator is. So then again, we would have this fraction, and as the numerator grows, so must the denominator, and they can never catch up with each other, so they can never be written as a fraction. So it seems that some of our square roots can't be written as a fraction, and they're irrational. But some of our square roots that come out to be nice whole numbers, which happen to be perfect squares, these are, can be written as fractions. They are rational numbers. And then, of course, we have our fun pi, 3.1415, and a whole bunch of other numbers. It's famous because it goes on and on and on. It's the relationship of a circle's circumference and diameter, and we'll talk about that later this year. But again, it's an example of this fraction that can never be completed because the decimal keeps going on and on and on. And so therefore it cannot be written as a fraction. All right, so yeah, again, I told you that we were going to talk about decimals, and we've just been talking about fractions for almost 9 minutes. So let's get to it. Let's study all of our rational numbers. And so you will see that this one, this one, this one, that one, because this is 5. This one, because it's 0.97 as a decimal, and this one all have something in common. These all terminate. And then we have this weirdo here. It doesn't terminate, but it does repeat. Okay. Well, let's study this over here. This doesn't terminate. This doesn't terminate. We said it was 2.236, and this doesn't terminate. Well, I can't just say that irrational numbers don't terminate because this doesn't terminate. It repeats. But you could say that it does not terminate and it doesn't repeat, right? Doesn't terminate or repeat. Okay, so these either terminate or repeat. If you want to be super technical about it and go back to the previous objective, these technically repeat endless zeros. But let's not overthink that today. These don't terminate and they also have no sign of repetition. So this is our big point. Big point. That rational numbers do end or repeat in their decimal form. And again, the opposite, the irrational numbers do not end or repeat in their decimal form. All right, I recommend that you have this nearby when you're doing your homework for reference. I think that a little bit of practice will help you get these skills down. I don't think it'll cause too much discomfort for you. Let me please explain what the homework is. So you have a bunch of numbers that go down the left side of your page, and your first challenge is to convert these to a decimal form. Now notice some of them are already in decimal form, like 4 is 4. You could, if you wanted to, do 4.0. 0.31 is 0.31. There's not a whole lot else you can do with that. But for example, 52%, we know. 52 of 100 or 52 hundredths. You may need to use a calculator for some of these, or your notes. I'm sorry, I should have mentioned, I'm using the redo side for sample questions. You should do the regular side for your homework, but sometimes I like to use the redo side to give you some, sample questions. Sorry, back to what I was saying. 31 over 99, because it's over 99, I know it repeats. So yeah, anyway, so once you have found the decimal form, then you'll go through and you'll ask yourself, does it terminate or repeat? For example, 4, yeah, that terminates. This terminates. This guy doesn't terminate. It's going to go on and on forever, but it repeats, so that's a yes. But this guy, this pi, that never ends, and it never repeats. So that one is a no. Okay, and remember our rule that we learned today. If a number terminates or repeats, then therefore it is a rational number. But if it does not terminate or repeat in decimal form, it is irrational. And also, we know that it can't be written as a fraction. That's just a little extra for you. All right, hopefully the regular side of this, the front side of this, goes smoothly for you. Now, if you have any troubles at all, please do not hesitate to, I'm looking for a free space here, to get a hold of me. Send me an email. I'm happy to help. I am at drones@d231.rochelle.net. Always happy to help, and you know where you can find me every morning or homeroom. Happy to help. Thanks a bunch for watching. Have a really nice night.